Hello everyone, welcome to Northern's Craft. So today we are going to solve uh, thermodynamics walkthrough problem. As in the first lecture we have solved the questions of compressibility factor. So now we are proceeding with the same type of question. Hope you can see the question in the question written over here. It says 1 kilomole of ammonia is filled in a zero point 0.6 meter cube vessel at a temperature of 200 degrees Celsius, having compressibility factor of 0.89. The value of pressure exerted by ammonia is megapascal. So we need to find the pressure exerted on ammonia. Given is 1 kilomole of ammonia filled in, volume given is zero point 0.6 meter cube, and the temperature given is 200 degrees Celsius. As yesterday also and the previous lecture also I have told you about, uh, we always take this Kelvin. So 273, which is equal to 473 Kelvin, and compressibility factor is given as 0.98. So we need to find the pressure exerted on the ammonia. So we know the generalized equation. PV is equal to Z N R dash T. So we need to find the P. P will be Z N R dash T whole divided by V, is going to be 0.98 into 1 into universal gas constant value is 314 into temperature is our 473 Kelvin whole divided by volume 0.6 p cube. Therefore, our value of the pressure will be 5.833 megapascal. This is the solution that we were searching for. Hope you understood it. We don't need to do anything, we just need to remember this formula and put the values over here. And by the way, we need to find the answer in megapascal. So megapascal's answer will be this. Make sure you know the units as well while you're doing the problem. As you can see over here, it's given in kilomole, and the unit of this 8.314 also in the this kilomole per kg Kelvin. So you need to be since these all are in kilo, so kilopascal we will get 5833 kilopascal, but I have converted into a megapascal, so you can see it. So now let's go into the second question. As you can see over here as well, I have how I've converted into the megapascal. So now let's go to the second question of the. So second question says, uh, a balloon of a spherical shape of diameter 10 meter contains H2 at 30 degrees Celsius and 1.2 bar. The mass of H2 uh, in kg in the balloon will be dash kg. Okay, actually the question is a little bit that the mass of H2 in the balloon will be dash kg. We need to find the mass of balloon. Okay, mass of H2 in the balloon. This is our objective. And assume hydrogen as idle gas. Okay. So molar mass of hydrogen is, firstly you need to check that molar mass of hydrogen will be 2. As we know the atomic number of hydrogen 1. So molar mass will be 2. 1 plus 1 will be 2. The balloon is a spherical shape of diameter 10 meter. Okay. Then the volume of sphere will be pi by 6 into d cube. Simply following the simple formula, pi by 6 d cube is the formula of volume of sphere by using diameter. Okay, and pressure is given as 1.2 bar, which is going to be 1.2 to the power 3 5 pascal. But we usually find the answer in as it given in kg. Okay, kilogram. So you need to convert into kilopascal. 1.2 into 10 to the power 3 kilopascal. 10 to the power 2 kilopascal. Okay. since 10 to the power for 3 will be converted over here. uh, wait for a minute. Okay, let's convert it the unit. 2 into these are 5 zeros, one over here, one. So um, you need for we know uh, millicentidecimeter deca hectokilometer. So uh, 1 kilopascal is equals to 10 to the power 3 pascal. So obviously the answer will be 1.2 into 10 to the power 2 kilopascal over over here, like that. So this is pressure, our given pressure, and in the balloon we need to find the now the mass. Okay, so we know the generalized equation. PV is equals to MRT. We need to find the mass and ZMRT. Wait for a minute. Okay, compressibility factor is not given, then Z is not there, since Z value will be 1 for ideal gas. uh, M value will be then or M will be PV open RT. As we know, R is characteristics gas constant, which is universal gas constant by molar mass. So M's value will be pressure 1.2 into 10 to the power 2 into volume is given as pi by 6 into 10 to the power 3. Diameter is 10 meter, whole divided by universal gas constant 8.314 divided by molar mass is 2 into temperature is given as our temperature is given 30 degrees Celsius. Okay, temperature is given as 30 degrees Celsius, which is going to be converted into 273 plus 30 will be 303 Kelvin. So multiply it over here, 3 Kelvin. Your answer will be 49.883 kg. This will be your answer, since we needed the answer in kg. Hope you understood how we have solved this problem. You don't need to do anything again. Okay, when the case, oh, simple, for compressibility, compressibility factor for ideal gas Z will be 1. Just put the values in this formula and find the value of M. That's simple. Yes, I've solved it over here as well. Now let's solve the last question for today. So this is question number 3. So I'll ask you all to try to solve it by yourself. Okay, try to solve this question by yourself. Pause the video and try to solve the question by yourself. 1, 2, 3. Have you tried to solve the question? Pause the video. Got some idea? So now let's solve it. 1 meter cube rigid tank has a propane at 100 kilopascal and 300 Kelvin and connected by a valve to another tank of 0.5 meter cube with the propane at 250 kilopascal and 400 Kelvin. The valve is open and final temperature of the propane in the both tank is 325 Kelvin. The final pressure of the propane will be dash kilopascal. So two tanks are there. Tank A, which have a volume of 1 meter cube. Tank B, which have a volume of 0.5 meter cube, and they both are connected by a valve. Okay, they both are connected by a valve. They both are connected by a valve, and let's consider this is A, this is tank B, and tank is not open right now. Okay, the volume of the tank 1 is 1 meter cube. Volume of tank A is 1 meter cube. Volume of then pressure at tank A is 300 pascal. 300 no, 100 pascal, 100 kilopascal, and temperature is 300 Kelvin. Similarly, in valve 2, our volume is 0.5 meter cube, and pressure is valve 2. Pressure is Our pressure is 250 kilopascal, and temperature at second tube is 400 Kelvin. The valve is opened. Then the valve will be opened. Okay, afterwards, valve will be opened, and the final temperature on the both the tank is the final temperature as the valve is open will be in the both tank will be 325 Kelvin. We need to find the final pressure of the propane in kilopascal. Assume propane as idle gas. Okay, so uh, PF VF is equals to uh, our we need to find the final pressure of the propane. Okay, final pressure of the propane. M F R T F MRT. You know, this is a formula for final final ideal gas equation when the both the like tankies propanes are mixed up. So we need to find the final pressure. Our objective is find PF. So PF will be equal to MF RTF all divided by VF. So MF will be is equal to MF MF will be equals to MA plus MB. Okay, MA plus MB. No, and our VF will be equals to VA plus VB. So now what you need to do is, as we know the formula of PA VA will be equals to MA RTA. So MA's formula will be PA VA divided by RTA. Similarly, MB's formula will be PB VB RTB. So just simply put this formula in this equation and you will find the value. You don't need to do anything. Okay, let's solve it. Let's solve it. Now our equation will be PF will be MF as we have already reached here, VF. So this will be equals to MA plus MB RTF whole divided by VA plus VB. Furthermore, this equation will be PAVA whole divided by RTA plus PBVB whole divided by RTB RTF whole divided by VA plus VB. R can be cut from here. Simply put the value of the given values. So given values are is given over here. Okay, so pressure at 1 will be 100 kilopascal 1 meter cube whole divided by your TA 300 Kelvin plus PB 250 kilopascal into VB is equals to 2.5 meter cube whole divided by 250 kilopascal whole divided by VA plus VB 1 plus 0.5. Therefore, after calculating, you will get PF as equal to 135.93 kilopascal.